And where'd you say begin? 15?
Yes.
Okay. The way you want to treat all of these is as transformations.
Right.
So what's the parent function on 15? Y equal what?
Uh, Log. Oh,
That
yeah.
right there. Okay.
Okay.
If I graph that, it looks just like that. This point is a key point. No matter what the base is, it's going to go through that point right there. Whether it's log base 2 or log base 17, does not matter. They all are going to have this shape. They're all going to go through that point. The only difference between log base 2 and log base 17 is the steepness of that curve.
Okay.
Okay? So what's the consequences? What's happening there? The only thing that's different than the parent function, what is it?
So,
What's the consequences of that plus 1?
that moves the vertical asymptote up
Which way and how much?
to the left one.
Correct. In other words, what we have in this picture is a vertical asymptote for the parent function. That's where the vertical asymptote goes. Well, since we're making a horizontal shift, we're going to shift all vertical asymptotes. So that is our new vertical asymptote. And our new graph now, instead of going through that point, is going to go through that point. 0, 0. And notice that that works. If I
Yep.
plug in 0 for x, what's the log of 1? 0.
Okay.
Okay, so that's all that is, horizontal shift. The key
Right.
to most of these is really knowing how to draw the parent function. So if you're looking to practice, there's like 8 elementary parent functions that they want you to know how to draw from scratch. And if you can do that, then I know you know all these transformations. You're always correct. So the only thing you might not know is how to draw the parent function. So that's what you should look at. I don't know if you have a book or not, but a lot of algebra books will have one page with all of those parent functions. Just familiarize yourself with them as to what they look like.
Okay.
All right. So if I'm going to simplify that, what am I going to do?
So,
When you subtract 2 logs, and I want to put that into 1 log only, what is it?
oh, you divide the exponents, right?
Huh? The log base 3 of 21. That's what 81 divided by 3 is.
Wouldn't it be 27?
Thank you. I knew 21 wasn't correct because now I can't figure out what that is without a calculator. But I can figure out what that is now. If I said, what is the log base 3 of 27? What is that? Do you know? Without your calculator?
Yeah, it's 3.
Yeah. In other words, it's equal to some question mark number, which means 3 to some question mark power has to equal 27. Well, that question mark has to be 3.
Right.
All right. You actually could have gotten there without putting them together. Let me just show you that, just so you're aware. This right here is the number 4. This right here is the number 1. So 4 minus 1 equals 3. They could have also done it that way.
Oh.
Notice
Okay.
that that's 4 because 3 to the 4th power is 81. And this is 1 because 3 to the 1 power is 3.
Okay.
So you have choices on these, but the fact, I don't know, I'm inclined to believe that the way they're looking for you to do these is by putting it together. In other words, by creating one log expression, and then you're going to be able to evaluate that log expression fairly easily. Let's do it that way anyway, at least for 17. So if you put that together in one log expression, what is it?
So it's 16 to the 3rd.
Well, first of all, what we're going to do is take that coefficient and make it an exponent. So that becomes 4 to the 3rd times 4.
You do that first. Okay.
Yes, you want to do these in a certain order. So that becomes 4 to the 4th, which is 16 squared, which is 256.
Okay.
Now, 2 to what power is equal to 256?
I don't know.
Well, I'll tell you how I always remember it. 2 to the 10th is approximately 1,000, which means 2 to the 9th is half of that. 500 must be 2 to the 8th. The hard way to do it is to remember that's 2 to the 1st, that's 2 squared, that's 2 cubed, that's 2 to the 4th, that's 2 to the 5th, that's 2 to the 6th, that's 2 to the 7th, and that would be 2 to the 8th. But doing it that way, I have to go through 8 numbers, doing it starting at 2 to the 10th and working my way backwards. I only have to do 2 steps. This is a good thing to just know approximately. 2 to the 10th is approximately 1,000. It's actually 1,024, but it's approximately 1,000.
Okay.
So 2 to the 20th must be approximately 1,000,000, because 2 to the 20th would be 1,000 times 1,000.
All right.
And again, you could do this a different way. You could say this is the log of 64 plus the log of 4. You'll get the same answer, whether you put them together or not. How about this one?
So
So a couple of ways to think about these, and I can't really tell how you're doing it. You've been pretty
0.
good so far. Okay, good.
So
Go into it if you know how to do it. But
yeah.
the way to do it is 5 to what power equals 1? That's the way to do it. 5
Right.
to what power equals 1? And any number to the 0 power is equal to 1. So that's true regardless of the base. Log base 17 of 1 is also 0. So the log of 1 is always 0. About that one?
It's 1.
Good. 20. What's the general formula for continuous growth?
So P continuous, so then E and then RT.
Good.
The exponent, RT.
And the RT are both in the exponents.
Right.
It's not, R is not down here on the algebra line. Okay. So let's see what we've got. They stashed away 4,500, so P is 4,500. 18 years later, the balance is this. So I can begin to write an equation. Tell me how much I can write at this point right here. Tell me what I can fill in for all my letters here. I need an A, I need a P, I need an R, and I need a T.
So P would be the 4,500.
No. Dashed away, that's what they started with, 2001. This is what it grew to.
Oh. So would that be A then?
Uh-huh. So it's 8750.91 equals what?
P.
Which is 4,500.
Oh.
The number. That's not a variable. R?
And then
No, they didn't tell us what R is. They did tell us what P was.
18.
Now, I have an equation that only has one variable, R. First question, at what rate is the money growing? Well, we got to figure out R. How to solve that for R. Do you have your calculator? You're going to need a calculator for this.
1 second, let me grab it. All right. So
What's the first step?
divide by 4,500.
Good. What do you get?
Uh, 1.94.
So that's now equal to E to the 18R. Now what? How do you solve when the variable is in the exponent? What do you always have to do?
So my teacher calls it unrolling. So you bring the E over to the other side. So then.
No. Just take the natural log of both sides.
Oh.
I mean, I don't know what she means by unrolling, but the solution here is very straightforward. I'm going to take the natural log of the left side. That's a number. I'm going to take the natural log of the right side. Now, what does that allow me to do? What is the natural log of E to the 18R?
It's 1.
No, it's whatever that is.
Oh.
Remember that the log base of that number is always 1. So you're right. I think what your teacher meant was this. You get to bring the 18R down in front.
Yeah.
So that's what that's equal to. But because it's natural log, the natural log of E is 1. So I can just cross that off and replace it with 1. So what's R equal to? Precisely By that I meant that's what R is equal to. And then I realized, well, that's not really precise because we already rounded it off. In other words, that 1.94 was rounded off, correct?
Yeah.
Okay. So since we already rounded it off, that's okay. That would be a sufficient answer. More specifically, if you wanted the exact answer, this is what it would be.
Okay. Yeah.
In other words, that is not rounded off. There you go. That's what R is. But for our purposes, go ahead and turn that into a number so we can continue. It's too hard to work with those exact answers, the two involved.
Okay.
So what's the natural log of 1.94 all divided by 18?
0.0368.
0 point, what, 0 what?
368.
So what's the interest rate? What rate is the money growing at?
3.68.
Correct. Correct. In other words, this number is always in a decimal. Hold on, let me shut the door so my dog doesn't present such a distraction. So now what is our precise formula? What is our formula for this problem? Write a function to model what the amount is after some number of years. I'm going to write it up here on the top left. A is equal to what?
8,750.
No. They want a general function.
Oh.
Money, A, in terms of the number of years, T.
Okay, so A equals,
Actually, I'm wrong. I'm actually wrong. For this question, I just reread the question. They do want P to be 4,500. But now the rest of it are all very, well, in other words, E doesn't change. R, we just figured out, was 0.0368 and times T. And there's our answer. In other words, there's the function we would use if we wanted to know what the money would be worth in 25 years or what the money would be worth in 10 years. This is what you would use. How long does it take for the money to grow to 12,000? Show it algebraically. So I'm erasing everything on this side because we've got our function. So how do you answer number C?
So you just solve that equation, right, for A.
Right.
So,
What's A?
12,000.
We know what P is still, 4,500. E, we know what R is, 0.0368 times T. T is the unknown. They want to know how long it would take to grow to 12,000. We can see that it took 18 years for it to grow to 8,700. So let's solve this. How do I solve this? Next step?
Divide by 4,500.
Yeah.
Oh, one sec.
What's 12,000 divided by 4,500?
2.6 or 2.7. round it off.
Okay, now we got this. And what's the next step?
Natural log, both sides.
On both sides. Once you take the natural log, this whole thing becomes the exponent. Over here, we still have natural log 2.7. So time is going to be the natural log of 2.7 divided by 0.0368. Go ahead and come up with that number. Should be in the neighborhood of 24 years, I'm guessing, 25 years.
26.
Okay.
9.
It's always a good idea to know what the ballpark should be. Just so you know that if you come up and you're off by a factor of 10, you've done something wrong.
Yeah.
All right. 21. How do you find the inverse of a function?
Swap x and y and then solve for y.
Yeah, only we don't have a y here. So the first thing we're going to do is change f of x to y. That's permissible. That doesn't change anything. Okay. Tell me, read line by line for me. Next line.
So x equals 3 exponent y minus 2 and then plus 4.
Now solve that for y.
So minus 4, so x minus 4 equals 3 to the y minus 2. And then natural log.
I always use natural log, whether it's e or not. Okay, so I want to put parentheses around that. I'm going to take the natural log of that. And I'm going to take the natural log of that. Now, the right side becomes y minus 2 in front, that exponent comes down, times the natural log of 3. Okay, what's the next step?
Then
Natural log of 3 is just a number. If you had a number in front of that y minus 2, what would the next step be?
divide by the natural log of 3.
Okay, that gets rid of that. Now what? Remember, I'm solving for y.
So then add 2.
Correct. You got to be a little careful about how you write it. It does not go in the numerator or the denominator, but outside. So that is f inverse of x. And I didn't really need to call it y, but most people are taught that to solve for inverse, you swap x and y. So it's an easier problem if you start it out in terms of x and y and not in terms of f of x. But when we get to the end, it's kind of important to call that f inverse of x. That's no longer y. If this was y, what we have, if this was y, then what we have at the end is definitely not y. It is f inverse. Okay. The next one looks easier. Need to do it?
Let's see. The g of x.
You see why I say it's easier? It has one less thing involved. That one had that one. This one just has x.
That's fine. Yeah, we can skip it.
In other words, first step is I'm going to subtract 7, and I'm going to take natural log of both sides, and then I'm going to have x defined.
Yeah.
Okay. 22. let's see, yeah. Is this the whole page that we need to do today? Or are there more?
This is it. This is the last page.
Let's do 20, 23, and 24, and if we still have time, we'll go back and do that second one on 21. Okay?
Okay.
I wasn't sure how many we had to go here. Okay, so the graph is given. What kind of graph does that look like? Just don't look at anything else in the problem. Well, sorry, I looked at the next sentence and it tells me what it is. But when you look at that graph, it looks exponential. It's not parabolic. Doesn't look like a parabola. It looks exponential. Anything that grows that fast is usually exponential, okay? And so they're telling us what the parent function is. What must this function be if the parent function is 3 to the x? First of all, let's graph the parent function. Parent function is going to look like this. And this point is always the same in an exponential. That, by definition, goes through 1, 0. So, and we have this asymptote, the horizontal asymptote, right there. So first of all, what's happened to the horizontal asymptote?
It was moved down
By? How much is that dotted line below the x-axis by?
5.
Then that's what it is. So horizontal shift down by, a vertical shift down by 5 would look like that. Okay? We haven't determined yet what's going on horizontally. We'll try. It's a little more difficult to figure out what's going on horizontally, but we can figure out what's going on vertically really easily by just noticing that the horizontal asymptote is down by 5 units. Now, if nothing is going on vertically, or horizontally, then the key point right here should have moved down to minus 4, 0. Well, is minus 4, 0 on this curve? Yes, it is, right there. In other words, there is nothing happening horizontally. That graphs that function perfectly. Every point on it. If I plug in 0 for x, I get 1 minus 5, which is minus 4. Let's just check that. How would I get that? Well, if I plug in, or actually, let's check this. That looks like a point we can work with. If I plug in 2 for x, well, now I've got 3 squared minus 5. I should be around 4, and I actually am. It's just you can't read the graph that accurately. But I'm close enough that I'm now confident that I have the correct chart. There's no other transformation going on other than a vertical shift. There's certainly no horizontal shift going on, and it doesn't appear that there's any vertical stretch either, because a vertical stretch would show up when I go to plot that point right there. If I had much of a vertical stretch, then that point wouldn't be on the curve.
Right.
All right, so we got 3x minus 5 is that curve. That's y equal 3 to the x minus 5. So that answers A. Write an equation as a transformation of f with a horizontal translation of 3 units to the left. Now notice they said a transformation of f, not a transformation of h. So we're starting, this is f right here. That's f of x. In other words,
Okay.
f was a transformation of h, right? That's how we got from 3 to the x to 3 to the x minus 5. Now they want us to transform f 3 units to the left. What's that look like?
So that would be
F of g of
x.
x. As long as I call it something different than f or h.
So x or 3, and then exponent x plus 3, and then minus 5.
Perfect. Using interval notation, state the domain and range of f, which is this function here. The domain on that.
So from -0 or negative infinity to infinity?
Correct. In other words, there's 2 ways to do these. You can do them algebraically or you can do them graphically. If I think of that algebraically, I realize that I can use any value for x that I want. I can have any negative number, I can have 0, I can have fractions, I can have infinity. So there's no restriction on x. And if I look at the graph, I realize x goes all the way to negative infinity in that direction, and x is going to go all the way to positive infinity in that direction. Even though it doesn't look like it goes to the right, it does. I obviously can put in big numbers for x. Now, the range is actually quite a bit easier to read the range from the graph. So interval notation on the domain is negative infinity to positive infinity, and the range
is from -5 to infinity.
Parentheses or a bracket that goes on the left?
Parentheses.
Correct, because it never can be -5. It never gets to -5. No matter how far to the left I go on the x-axis, my range just approaches that asymptote. It never actually hits there. There's no value of x that will make this value be -5. Okay, I'm at 23.
So
what's the first thing I should do if y equals 4?
put 4 in for y. So yeah, 4 equals 4 times log base 3 times x.
Now what?
Then divide by 4. So it's 1 equals log base 3 times x.
Now what?
3 to the 4th. Or so 3 to the 1 equals x. So that's 3.
Correct. In other words, the way you solve log equations is you turn them back into exponentials.
Right.
Okay. About x equal 27. So we've got y equals 4 times the log base 3 of 27.
And so the log base 3 of 27 is 3, and then 4 times 3 is 12.
Yeah, and notice that that's easier then taking that 4 and making it an exponent.
Mm-hmm.
Now I got to take 27 to the 4th power, and I'm going to have to bring out my calculator to solve all of that. So just because you can compress something doesn't mean you always should. This problem is far easier to solve the simple way that you did it.
Yay. All right.
And I meant that as a compliment. Now, you always want to do these things in the simplest possible way. So, okay, so number 24. Now, this is also compounded continuously. You know there's 3 different formulas, right?
Yeah.
Okay, good. So let's write our general formula. That's always a great way to start a problem. If you don't know how to start it, start with the general formula. Now fill in as much as you can. And what you're going to find out is that you can almost always fill in everything but one variable.
Okay.
Then it's just a log problem.
So, the 7% is R, so that's 0.07.
Okay.
And then the 1,500 is P.
Okay. What's A going to be?
Oh, double, so it's 3,000.
Yeah. And there's actually, I don't need to know what P is. All I need to know that at A is equal to 2P. Notice what happens. In other words, this is not a function of that. This is a function you want it to double. So 2P equals P times E to the 0.07T. Notice the P's cancel. That's why it doesn't matter what your starting principal is. It doesn't matter if you start with $100 or $1,500. It's going to take the same amount of time to double. And if I do it the hard way, well, not the hard way, but the other way, I still get the same thing because the first step is to divide by 1,500, and I get 2 on the left. And now on the right, I get this. And these are getting pretty natural for you.
Mm-hmm.
That's what T is going to be. See how I did all of that? That's not a negative sign.
So, negative natural.
In other words, I took the natural log of both sides. And on the right side, that left me 0.07T. Got to get rid of the 0.07, divide both sides by 0.0.
Okay.
So whatever that number is, ballpark figure, 8 years, 10 years, somewhere in between. What is that number?
So it's negative or 9.9.
So at a 7% interest rate, compounded continuously, it doesn't take as long as you think to double it. You would think it would take 15, right? But because it's compounded continuously, it takes less than 10 years, even though you're only getting 7% a year. You would think 7% times 10 years is 70%. You wouldn't double. But the continuous compounding is what causes it to double.
Yeah.
All right, let's go back and do that one problem we didn't do. This one right here. Find the inverse of that.
So, all right, so it's y equals 2x plus 7. Or to the x plus 7, yeah. And then x equals 2y plus 7. And then subtract 7. then natural log.
Just be careful with parentheses here. In other words, you have to add some parentheses. If I don't add those parentheses, it's not the same answer.
Okay. And then equals natural log of 2 to the y. Or, yeah, y.
Actually, the y goes down in front after I've taken the log of it. Now I can, that's the only thing that allows me to take the exponent down in front after I've taken the log of it. So y is going to be that divided by natural log of 2.
Okay.
The domain of my answer.
So.
And that is actually G inverse of x. What is the domain of it?
So, the domain of it?
Always think about what x can't be.
All right, so x can't be 7 and x can't be 0.
Can't be anything less than 7. In fact, x has to be greater than 7. Can't be 6, 5, negative 10, negative 100. In other words, this argument has to be greater than 0. So x minus 7, start there, greater than 0, x greater than 7. It's simple as long as you set up that first step. And that's the best way to do domains, is to just write it out as an inequality or an equation.
All right.
Okay. All right, Dimitri, can you mention to your mother whether she's had a chance to take care of that envoice?
Yeah, I'll ask her.
I haven't noticed it being paid yet. So I guess what I'm asking is, can you give her a nudge?
Yeah.
Thank you. And we'll talk to you next Tuesday.
Yep. See you next Tuesday.
At 7, right?
Yeah.
Okay.
That can work. Yeah. Unless, can you do the 3 to 4 again, actually, if it's still open for Tuesday?
I believe I can, yeah.
Okay, because I don't have track anymore, so it would be unnecessary to.
Hold on. You can't do 3 to 4. Yeah, I can do 3 to 4. Yeah, you want to do 3 to 4?
Yeah, it works.
Okay, hold on. You got it. I will talk to you next Tuesday at 3.
All right.
Okay.
All right.
Dimitri,
Bye.
talk to you next week. Bye-bye.
Okay. Bye.